My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. This time around on AutoVision News Radio, I really get to be the student. I wanted to brush up on my knowledge of LiDAR and its applications, and then Moore's Law, which is fundamental to the work our friends in the semiconductor world are doing and something that impacts automotive as well. To help me is Angus Pacala, Chief Executive Officer of Ouster. He co-founded the company in 2015 to make LiDAR both digital and ubiquitous. Prior to Ouster in 2012, he co-founded LiDAR company Quanergy Systems and served as Director of Engineering until 2015. Angus holds a bachelor's and a master's degree in mechanical engineering from Stanford University. After taking me through LiDAR 101, Angus shared the origin story of Ouster and some of the company's innovations. We take a moment to examine then the spec sheet on those innovations, which is pretty cool. And then finally we hear more about Moore's Law and Ouster's desire to make the world a better place through the application and deployment of LiDAR. Starting with the basics, I asked Angus what LiDAR is and how it works.
LiDAR is an acronym, and it stands for Light Detection and Ranging. And it may be familiar because it comes in a long line of other detection and ranging technologies like radar, sonar, and even echolocation with bats.
Right.
And so the fundamental principle across all those is that you emit some energy, whether it's sound with echolocation or sonar, or radio waves with radar, or light waves, photons with LiDAR, time how long it takes to get to the target, and bounce back to you. And then you know the distance because you know the speed of light, or you know the speed of sound in water or in air, and you can calculate the distance to a target. And if you do that many, many times, then you can get many, many different 3D points around you. And that's what LiDAR does with light. So it's the light version of this detection and ranging principle.
Building on that foundational definition, Angus then helped me wrap my mind around how machines, like a car for example, can utilize LiDAR.
So the progression here from sonar to radar to LiDAR is actually a dropping of wavelength, which allows you to get tighter and tighter and tighter with the focusing of your beams. With basically, the better the measurement you get, the more precise the measurement you get. So you can focus these tiny little laser spots all over the world and get a really rich, accurate, and precise, basically sharp view of your 3D surroundings. And that is what a machine needs if you want to make it autonomous. A machine needs to understand its surroundings in perfect 3D so that it knows, oh, there's something directly in front of me, 5 meters away, it's moving at 3 meters a second, and I'm going to avoid it. You want to know where the ground is. You want to know where people are. You want to know where cars are. You need to know all of this information at really high accuracy, really high resolution in 3 dimensions, and feed that into a computer program to make sense of it. So LiDAR is the perfect sensor for doing this. It's the best known technology for giving a computer the eyes to see the world.
Ouster is a digital LiDAR company, and at the opposite end of digital is analog. Fun backstory, when I was in broadcasting school in 2003, I learned how to cut and splice tape. It's manual audio production. And in 2003, there were already digital programs for radio and audio production, but it was still taught to us. In one of the smaller production studios, Iowa Western had an old reel-to-reel console. And you have a bunch of tools that you need to edit your audio. So there's razors, a ruler, grease pencil, different types of tape like timing tape and leader tape. It's pretty time intensive. And the application of, say, a digital program like Adobe Audition, which is what I edit AutoVision News Radio on, it cuts your production time down so much. All of my audio files are on my computer screen, and the only tool I need is my mouse. When I worked in AM radio, this is back in southwest Iowa, near where I grew up. This would be right in the middle on I-80 between Omaha and Des Moines, like an hour each way. So right in the middle between those two cities. But during the summer, we had up-to-the-minute coverage of severe weather. And having a digital audio editing program meant that we could get important weather news out over the air quicker versus doing analog editing. What's interesting is how Angus and I are now speaking the same language, different industries, different applications, but we end up on the same page when it comes to why the move from analog to digital will yield significant benefits.
Most technologies start analog. They start in the analog world. And you can think about analog computers back in the 1950s, analog cameras that you probably grew up with film.
Sure.
And at some point, silicon technology, CMOS digital technology comes along and a company innovates and takes an analog technology and makes it digital. And that's what Ouster is doing with LiDAR. And what that actually means is that we have taken the complexity of an analog LiDAR that has thousands and thousands of components and made a single custom CMOS digital chip, a single piece of silicon with over 100 million transistors on it that can do everything that an analog LiDAR could do, but it can do it on that single piece of sand, that's silicon, and it can do it at much lower cost, higher affordability, better performance, lower power draw. It's kind of all the benefits that you associate with digital technology, like the things about your smartphone and why it gets better every year, why your digital cameras get better every year. That's what we've done with digital LiDAR is put it on a chip and make it affordable and ubiquitous for people. There's so many benefits to that. If we can make cars that don't crash, if we can augment industrial machinery with better safety so that people have a safer working environment and a working environment that can accomplish more. Because it's more efficient. Those are exciting things that impact quality of life. If your crosswalk could know that you were waiting there and that it should go green and wait a little longer because you're taking a little while, or your grandmother or grandfather is taking a little while to cross the street, that's the kind of thing that giving sight to a machine like a crosswalk actually enables you to have a better world. That's what interests me at its core. In 2015 with Ouster, what I realized was actually this trend around analog to digital technologies and how digital technologies basically always win and dominate the markets that they're introduced into. And that was the founding principle of Ouster. Let's make the first digital LiDAR. Let's put LiDAR on a chip. It's as simple as that. The concept in and of itself is put digital LiDAR on the chip and then improve digital chips over time. And your LiDAR technology will get better and better and better. And kind of a corollary to that was when you go digital, the technology is more affordable, it's more flexible, it's more capable. It applies to many more markets. Diversification across markets was another founding principle of Ouster. Let's make technology that works not just for autonomous vehicles, but for industrial machines, for crosswalks, for smart infrastructure. We could do all of that at once with the right product and technology driving it.
I then asked Angus about the company's latest press release, and here's the title. Ouster launches new Rev7 sensors with double the range powered by breakthrough L3 digital LiDAR chip. And this one is fun because we really got into the raw performance.
Yeah. So this is cool on a couple levels. The top line title is kind of that we have doubled the performance of our LiDAR systems. And that's great for customers. But it's also cool from a technology standpoint because how we've done that is actually by making another CMOS digital chip called the L3 chip that's actually 10x its raw performance, which because of some laws of physics, only 2x's the performance of the end LiDAR and the specs that customers care about, which is still an immense doubling the performance of a LiDAR system overnight with just a silicon CMOS chip change is unheard of. It's never happened before. But what this shows is actually the title, the launch is Rev7. And that is the 7th revision of our technology. And it includes the L3 chip, which is the 3rd generation architecture of our silicon CMOS. And so Ouster's 7 years old. We've done 7 revisions. We're on our 3rd chip. And this is the whole digital story. This brings us back to we are out competing our competitors. We are building better products more affordably with better performance because of the silicon CMOS and our ability to iterate and take advantage of exponential improvement in that silicon CMOS semiconductor.
In that press release, there's a line, and I quote, "With the extended range of Rev7, we are unlocking an all-new category of long-range and higher-speed use cases, essential for many robotaxi, shuttle, bus, and truck operators." I asked Angus what his thoughts are on all these different and unique use cases.
The exciting thing here is there's no limit to customers' demand for the ability of a LiDAR system to see farther out, have better range, to see at high resolution, see smaller and smaller objects at long range. And that's what we're delivering with this. So, if you want to see, our longest range product now sees over 400 meters in all directions. So when you're driving down the highway and you have a big sweeping on ramp or off ramp, you could see the entire thing illuminated in the LiDAR data.
Right.
And know that there's a backup on that big sweeping thing that's going off to the right or to the left. So it's unlocking not just that kind of forward-looking long-range use case of driving straight down the highway and making lane changes and great automated cruise control, but truly 360-degree quarter-mile situational awareness and doing it at immense resolution. So the products are outputting 5 million points of data, 5 million 3D points of data a second. And again, this is all just made possible by that L3 chip, which has over 100 million transistors doing calculations
That's cool.
and ingesting basically over 1 trillion photons a second.
Yeah.
And then calculating at the end of the day 5 million points of data that it's feeding into a computer to keep you safe while you drive your car down the street.
This press release we've been talking about, Angus mentions Moore's Law. He's quoted in the press release and cites Moore's Law. Like my LiDAR 101 lesson, I asked Angus to walk me through Moore's Law.
Moore's Law is named after Gordon Moore, who was an Intel co-founder. And he posited that every 18 to 24 months, the number of transistors on a silicon chip would double. And, it's easy to say, well, sure, that's going to happen for 10 years and it's going to be 2 to the 10th, and that's 1,000 times better. But it's actually happened for 70 years. And having Moore's Law continue for 70 years is an astronomical achievement of basically all humans. It's really the only exponential trend in hardware that's ever held true for this long. And it's what has turned the early mainframe computers that were housed in a huge building into, the smartphone in your pocket. It's taken that complexity, that analog computer, and put it in your pocket and made it 1,000 times more powerful than that early computer, and it's 1,000 times cheaper. It's such a big change. And what it is this year in and year out improvement in silicon semiconductor technologies that allow you to pack more transistors and more capability into the same area. And that law drives smartphones, cameras, LiDAR now, radar in cars, your GPS, everything that you interact with that's the internet has been driven by Moore's Law and made possible by Moore's Law over the last 70 years. Once you wrap your head around it, it's a pretty impressive achievement that the collective semiconductor industry of the world has kept this going for so long.
Finally, I asked Angus, as a leader in automotive and during a time of rapid transformation in the industry, what he wants his legacy to be at the end of his career.
It's what I've said about LiDAR, and that's what I'm focused on right now is it's a beneficial technology. Digital is clearly the way that this becomes ubiquitous and affordable for everyone to interact with a LiDAR sensor every day and have LiDAR sensors keeping everyone safe every day, whether you're aware of it or not. I'm kind of 100% focused on Ouster until we achieve that goal. I think we still have a long way to go, even though we've come a long way.
To learn more about Ouster, visit the company's website at ouster.com. That's OUSTER.com. Ouster.com. You can also keep up with Ouster on Twitter and LinkedIn. In Detroit with Angus Pacala, I'm Carl Anthony, AutoVision News Radio.